find the constant of integration. And to do that, what we need to know is the equation of the curve, and we also need to know the coordinates at a specific point on the curve. So now we shall attempt these questions as I demonstrate how we then find the constant of integration. Okay, so let's begin with number one. With number one, we are told to find the equation of this curve, right? We are told to find the equation of each of these, right? So for the first part, we've got dy by dx being equal to 3x squared minus 6x plus 2, and we're also given the point at this curve, which is minus 210. So what do we know? We know that if we integrate this derivative, we'll get the equation of this curve. So for the first part, we shall integrate 3x squared minus 6x plus 2 with respect to x to get our y, right? So now let's integrate. The integral of 3x squared would be 3 times x to the power of 2 plus 1, which is 3 over 3, then minus 6 times the integral of x to the power of 1, that's x to the power of 2 over 2, then plus 2 times the integral of x to the power of 0, we are saying this is just x, then plus the constant of integration c. So we are saying this is the equation of the curve, right, for part A. But we have this c, constant of integration. So this is how we're going to deal with it. We shall simplify to get x to the power of 3 minus 3x squared plus 2x plus c. But we're given that minus 210, point minus 210 lies on the curve. So we shall now substitute, right, these points into this equation. And this is how we're going to find c being the constant of integration. So we shall say y is 10. 10 is equal to minus 2 raised to the power of 3 minus 3 times minus 2 squared, then plus 2 times minus 2, then plus c, such that 10 is equal to minus 8, and then minus 12, minus 4, plus c. And 10 would be minus 24 plus c. Taking minus 24 aside, it becomes a positive. C would be equal to 34. Therefore, the equation of the curve would be y is equal to x to the power of 3 minus 3x squared plus 2x plus 34. Right. And then as well, if we need to prove this result, if we differentiate this, we should get dy by dx being equal to 3x squared minus 3x squared minus 6x plus 2. And if we do that, we get that. So this is for part A. Now for part B, what we need to do, first of all, we have to remove these brackets, right? Root of x is x to the power of half. X to the power of half times x to the power of half, we simply get an x. And then x to the power of half times minus 3, we get minus 3x to the power of half. So to the power of half. So now we shall do the same thing. Let me write this properly so that it is a power. So to the power of half. So for the part B, we're just going to do the same thing. The only difference is that now we've got a different gradient function dy by dx. So allow me to erase this part for part A. Okay, so now for part B, we are saying that to get the equation, y would be the integral of the gradient function x minus 3x to the power of half with respect to x. Then if we differentiate x to the power of 1, x to the power of 1, we get x squared over 2 minus 3 times the integral of x to the power of half. This will be x to the power of half plus 1 to give us a 3 over 2 over a 3 over 2. Then plus c being the constant of integration. So now we shall say x to the power of 2 over 2 minus 3 times 2 over 3, x to the power of 3 over 2 plus c, which will simplify to y being equal to x squared over 2 minus 3 and 3 will cancel, 2x to the power of 3 over 2 plus the constant of integration c. And then now if we substitute the point 912, the point 912 lies on the curve, which is this gradient function. So if we substitute that point into this equation, we should get the constant of integration. So we're saying that 12 is 2, sorry, y is 12 when x is 9. 9 squared being 81 over 2 minus 2 times square root of x, we're saying root of 9, right, raised to the power of 3 plus c, which is 12 minus 81 over 2 minus root of 9 is 3. 3 to the power of 3, that gives us a 27 times 2, we get a 54 plus c, right? And then of course, if we say this is an equal sign, 54 plus 12, we get 66. Then 66 minus 81 over 2. 81 over 2 being 40.5. Right, this should give us the c constant, which will be equal to 15.5 or 15.5. Right, so this is c, such that the full equation would be y is equal to x squared over 2 minus 2x to the power of 3 over 2, right, plus c, the constant of integration, which is, let me rewrite this as an improper fraction, that will be 31 over 2, right. So this would be the full equation for part B. Now moving on to number 2. Number 2 is a bit tricky, but we'll work on it. So allow me to erase this part for part B. Okay, so now for number 2, we are told that a curve is such that d squared y by dx squared is equal to minus 8x. In other words, the second derivative is equal to minus 8x. And then the curve is a maximum point at x is equal to 1. And the point 2 minus 1 lies on the curve. Now the question is, find the equation of the curve. So for number 2, we're told that d squared y by dx squared is equal to minus 8x. So what do we know? We know that if we are to integrate d squared y by dx squared, we get dy by dx. So dy by dx would be the integral of minus 8x with respect to x. So this is just reverse, right? Differentiating dy by dx, we get d squared y by dx squared. So integrating d squared y by dx squared, we get dy by dx. And this would be equal to minus 8 times the integral of x to the power of 1, that will be x to the power of 2 over 2, plus c being the constant of integration, such that dy by dx would be equal to minus 4x squared plus c. But what are we told? We've got a condition, right? We're told that the curve is a maximum point at x is equal to 1. But what do we know about a maximum point? A maximum point is a stationary point, and at a stationary point, the gradient function of a curve is equal to 0. So we're saying minus 4x squared plus c is equal to 0. But we're told that at that maximum point, x is equal to 1. So we're saying 4 times 1 squared plus c is equal to 0. Then we get minus 4 plus c, such that c will be equal to 4. So that's how we find the constant of integration. So now we've got dy by dx being equal to minus 4x squared plus 4. But we're not yet done, because we're required to find the equation of the curve. So moving on from here, if we integrate this gradient function, we should get the function of x, right? Which we are saying that y is equal to the integral of minus 4x squared plus 4 with respect to x, right? And then now we're saying minus 4 times the integral of x to the power of 2, that's x to the power of 3 over 3, then plus 4 times the integral of x to the power of 0, that's just x, plus the constant of integration c. So we have this. Then now we shall use this point 2 minus 1, which lies on the curve, to find this constant of integration. So we are saying that y is minus 1 when x is equal to 2. So minus 4 times 2 to the power of 3, that's an 8 over 3, plus 4 times x, that's 4 times 2, which is 8, then plus c, such that minus 1 is equal to minus 32 over 3 plus 8 plus c. And then if we solve for c, then we are saying that minus 32 over 3 plus 8, and then we take it to the other side, it becomes a positive, then we subtract 1, we get 5 over 3. So c is equal to 5 over 3, such that the equation of the curve would be y is equal to minus 4x to the power of 3 over 3 plus 4x, right? Then plus c being 5 over 3. C being 5 over 3. So that's the full equation of the curve. That's how we do that. And then now for number 3, we're told that f prime x is equal to 8x to the power of 3 minus 4 plus 3x to the power of minus half. And f of 4 is equal to, this is 3. F of 4 is equal to 3, like that. Find f of x. So allow me to erase this part for number 2. So that we finish off on the last person. Okay, so now for number 3, right? We're told to find f of x given f prime x. F prime x is the derivative or the first derivative for this function. So if we integrate this, we should get f of x, such that f of x should be equal to the integral of 8x to the power of 3 minus 4 plus 3x to the power of minus half. And this is with respect to x. Then integrating here, we shall say 8 times the integral of x to the power of 3, that's x to the power of 4 over 4, then minus 4 times the integral of x to the power of 0, that's just x, then plus 3 times the integral of x to the power of minus half, that will be x to the power of half over half, then plus c. And this will simplify to 2x to the power of 4 minus 4x, then plus 6x to the power of half, plus c. This is our f of x. But we also have a condition which says that f of 4 is equal to 3. So we are now saying f of 4 is equal to 3, such that in place of x, if we put 4, right, 4 to the power of 4, that's, what? Let me write it as 4 to the power of 4 minus 4 times 4, that's 16, then plus 6 times square root of 4, root of 4 being 2, 2 times 6 we get 12, then plus c should be equal to 3, right? Such that now we are saying 4 to the power of 4 times 2, 4 to the power of 4 times 2, and then minus 16 plus 12, right? C, that will be 508. So C plus 508 is equal to 3. Then C would be 3 minus 508, which is minus 505. Like that. And then now, okay, so I need to correct, let's see, f of 4 is equal to 3. Okay, that's correct. So C would be minus 505, such that f of x would be equal to 2x to the power of 4 minus 4x plus 6x to the power of half minus 505, like that. And then like this, it will be complete. So this was looking at how we then find the constant of integration, and of course applying a bit of geometry, coordinate geometry, yeah, and so forth. Alright, so this was it. Please make sure you leave a comment, drop a like, and don't forget to subscribe. Thank you.